Hello, I am Sriyan Kundu and this is our project Farm Monitoring System, and I have developed this with my teammate Nirvan Roy for our farmers and for smart agriculture and development. So our table of contents consists of our problem statement, the solution, the innovation, the team, the budget and the various project stages. Here comes our problem statement. The project addresses the need for precision farm management by providing real-time monitoring of environmental conditions and pest threats through drone technology, soil sensors, and machine learning algorithms. Now comes our solution for our problem statement. Here is our objectives. Developing sensor-equipped farm monitoring drone, then implementing ML for our pest detection, creating disease detection system, enabling the crop recommendation, utilizing drones for cattle herding and a user-friendly farm monitoring software. Here comes our complete and seamless workflow, where we are presenting the entire work of our system. From the start to the drone simulation, the usage of the ML algorithms, the combination of the due nodes for the data collection, the camera feed, and the complete setup for the prediction and for the usage of the farmers and for our research purposes. Now comes our innovation.
Here is the making of our software.
Here is our seamless hardware testing for the drone. Here is our software.
Let's introduce the team members who worked behind this project. We have Sriyan Kundu as the software lead for the project and myself Nirvan Roy as the hardware lead for the project. Next, we want to share the budget that is required for making this project. We needed a sum of rupees 20,000 for making the hardware prototype and a sum of rupees 14,000 that included all the cloud costings and the computations. Next, we want to share the project stages. They are stage 1, which involves the development of the hardware prototype, the stage 2, which involves the development of the software, and the stage 3 that involves the deploying of both the hardware and software and establishing a connection between the two.
Hello, I am Nirvan Roy. So I will be explaining about the architecture. So whenever we deploy the system will have the due nodes which are placed at various locations on the farm, and the drone will fly over the farm. Whenever the drone comes in range of the connection area with a particular particular due node, data will be transferred from this due node to the drone, and hence we ensure a wireless communication system which is designed by us over the entire farm field in order to help the farmers take decisions more effectively. Hi, I'm Shreyan Kundu. So I will now focus on the communication system that is being established based on the concept of ad hoc network and opportunistic network. Here we are using MQTT protocols for connecting with the various due nodes using a DHCP server. The DHCP server is basically something that we are creating as a local network that is replicating the internet, in which the Raspberry Pi is communicating with the various due nodes and clustering all the data in the cloud and sending us without the internet connection. And then with the processing of machine learning and deep learning algorithms, we are accessing at the various locations of the field.
So this is our precision agricultural drone. So here we have the due node. The due node communicates data to the drone. The drone receives it, and we can see the data that is received by the drone in the dashboard.
This is the drone that we are using for our autonomous communication systems. So over the drone, I will talk about the circuit that we have been using. So we are using a Raspberry Pi, which is installed with the MQTT server on it. Without the help of internet, without the use of internet, we are making a private server of our own, which is communicating between the nodes. Here is the node that I am talking about. So this node will accumulate the data, store it in its memory, and the drone will collect the data from it. That is, this data will be flushed out into the drone, and then it will be stored on the drone. And when it returns to the base station, it will provide us with all the data for further studies. So this is the network that we are building. So for the internal circuit that we are using here for this due node is these. So we are using an ESP32 and we are using temperature probe, and for the capacitive soil moisture sensor that is being calibrated with the various wet, dry and semi-wet conditions, and the temperature probe that we are using of DF robot. In future cases, we are also trying to implement the pH sensor and for the different NPK sensors for our autonomous data collection and for their clustering. Okay, now let's focus on how it is communicating, right? So this is we are connecting a Wi-Fi network that we are building using DHCP and TCP protocol and a MQTT server. We are trying to communicate between these nodes and storing in the base station. So now let's focus on how the data is being displayed on the base station and stored in the base station.
So this is a web app that we have created that shows the Node-RED dashboard in the app. The app is multi-platform, so it can be used on any device. No matter whatever will be the underlying OS that works on that device. So here we can see the various data that has been sent by the various nodes. Currently we have two nodes as explained. The node 1 results are shown here and the node 2 results follow. So this is our entire workflow. So when the drone hovers over the field, that time the data that is collected by the due nodes that are placed at various locations in the field will be collected and sent to the drone. The data received by the drone can be viewed through this web app that has the capability to run on multiple platforms, such that sitting at home we can see the various statistics of our the field of the farmer.
So here is the data that is being stored in our CSV format that we are storing, flushing out from the drone and getting it from the main station. From this data, we can send it to the main people who are, or the clients that we are targeting, and they can work on these data. For present purpose, for establishing the communication system, we are using these data of pH, that is we are trying to establish, and temperature and moisture. So presently we are working on much more sensors to increase the data values, but the communication system is established. And that